You know that feeling when you catch a perfect tiny speck of snow on your glove and just stare at it? Well, today we're diving deep into that feeling. We're going to explore the whole chilly, fascinating world of snow, from how a single one of those crystals is born to its huge impact on, well, the entire planet.
And we have to start with the one question that everybody has wondered since they were a kid, right? Is it really true? Are no two snowflakes ever the same? Well, that question is going to be our guide as we uncover the hidden science of snow.
Okay, first things first, let's get one major misconception out of the way. Snow is not frozen rain, not at all. Snow crystals are actually born directly from water vapor. That means they go straight from being a gas to a solid, way up in the atmosphere. The stuff you get when rain freezes on its way down, that's sleet. Snow is something way, way more special.
So, what is the secret recipe for one of these intricate little crystals? Let's zoom way, way in and follow the secret life of a single snowflake, from the moment it's born in a cloud to its slow, gentle journey down to Earth.
It all begins inside a cloud, where it's below freezing. Water vapor, just water in its gas form, is floating around and it needs something to grab onto. It finds a microscopic speck of dust or maybe even pollen, and it freezes around it. That's the seed. From there, a tiny six-sided crystal starts to form. It just keeps growing, grabbing more and more water vapor until, finally, it's heavy enough for gravity to take over.
But why always six sides? I mean, every single time. It's not random at all. It all comes down to basic chemistry. The water molecule, H2O, has this really specific shape, and because of that shape, when the molecules lock together to freeze, they naturally form a super stable six-sided or hexagonal pattern. So every snowflake, no matter how wild its design gets, is built on that same six-sided foundation. It's just how water works.
Okay, so we've got its shape figured out, but what about its color? Why is a fresh blanket of snow this brilliant, almost blinding white? You know what? The answer is pretty cool, and it might not be what you think.
Get this. Snow isn't actually white. Seriously. If you could look at a single perfect ice crystal, the building block of a snowflake, it's translucent, it's clear, kind of like a little piece of glass. So if all the little bits are clear, why does a whole pile of it look white?
Well, it's basically one giant optical illusion. It's all because of something called light scattering. When sunlight hits a snowbank, it doesn't just bounce off the top. It enters this incredible maze of millions and millions of tiny, clear crystal faces. The light bounces and ricochets off all these surfaces in every possible direction. And because the entire spectrum of light, all the colors of the rainbow, is getting scattered equally, our brain just says, whoa, that's white.
Of course, as you know, not all snow feels the same. You've got that light, fluffy powder snow that skiers absolutely dream of. That stuff forms when it's really cold and the air is dry. And then you've got the other kind, the heavy, sticky, wet snow. That happens when the temperature is hovering right around freezing. It's got way more moisture, which makes the flakes clump together. Awful for skiing, but it is absolutely perfect for building a snowman.
And have you ever wondered what the actual difference is between snow, sleet, and this other stuff called groupal? Well, a quick look here shows it's all about how they're made. We know snow forms directly from vapor. Sleet, though, starts its life as a raindrop and then freezes into a little ice pellet on its way down. And groupal? That's what happens when supercooled water droplets freeze onto an existing snowflake, making it look like a little crumbly snowball. So they're all frozen, yeah, but they have totally different origin stories.
All right, let's zoom out from those tiny crystals and start looking at the bigger picture. Because when all those flakes pile up, snow becomes so much more than just pretty weather. It actually plays this critical role for our planet. It's like a protective blanket for the entire Earth.
Just look at this number, 90 to 95%. What do you think that is? It's the amount of air that's trapped inside a fresh, fluffy blanket of snow. It's almost entirely empty space.
And all of that trapped air is what makes snow such an incredible insulator. It works just like the fluffy down in your winter coat. Those little air pockets stop heat from escaping the ground. This creates a surprisingly cozy little world under the snow, protecting plants and giving small animals a safe place to ride out the winter, hidden from the freezing air above. And snow doesn't just keep the ground warm, it actually helps keep the whole planet cool. This is because of something called the albedo effect. Now, albedo is really just a fancy way of saying how reflective something is. And as we know, snow's bright white surface is super reflective. It bounces a huge amount of the sun's heat and energy right back out into space, which helps regulate the temperature for all of us.
But it's not just about temperature, it's also about water. A lot of water. Just look at this chart. A truly mind-blowing 80% of all the fresh water on our planet is locked away in snow and ice. The huge snowpacks that build up on mountains every winter are like giant, natural reservoirs. When they melt in the spring, they feed our rivers and provide essential drinking water for millions and millions of people.
But like any powerful force of nature, snow really has two different sides. There's the face of wonder and incredible beauty, and then there's a side that is full of real, serious danger.
Let's start with the wonder. You can get some truly bizarre stuff. Ever heard of thunder snow? It's exactly what it sounds like, a snowstorm that has thunder and lightning. It's super rare. Or how about watermelon snow? Up in the mountains, you can find snow that's pink and actually smells a little bit fruity. It's caused by a type of red algae. And then there's lake effect snow, where cold air sucks up moisture from a big lake and then just dumps unbelievable amounts of snow on the land nearby.
So you might be wondering, how big can a single snowflake actually get? While the largest one ever officially recorded was way back in 1887 in Montana, and it was supposedly an unbelievable 15 inches wide. That is bigger than a dinner plate. Now, it was probably a bunch of different crystals that all clumped together perfectly as they fell, but still, wow.
But then you have the dangerous side. A blizzard, for example, isn't just a lot of snow. It's a specific, severe storm with crazy high winds and almost zero visibility. And snow blindness is a real thing. It's basically a painful sunburn on your eyeballs, caused by all those powerful UV rays reflecting off the snow. And of course, there's hypothermia, which is a life-threatening drop in your body temperature that can happen if you get cold and wet and can't warm up.
And hey, since we did just mention a few medical conditions like hypothermia, here's our standard important disclaimer. Remember, all this information is just for educational purposes. If you have any real health concerns, you should always talk to a professional healthcare provider.
All right, we have covered a whole lot of ground, haven't we? From single molecules all the way up to entire mountain ranges. So let's wrap this all up and lock it in with a quick summary of the 5 biggest things to remember about snow.
Here we go. Number 1, snowflakes are crystals made from vapor, not frozen rain. 2, snow only looks white because of scattered light. The crystals themselves are clear. 3, it's an amazing insulator because it's mostly trapped air. 4, it's absolutely critical for our planet's climate and for our fresh water. And finally, the answer to our big question from the beginning. Is it true that no 2 snowflakes are alike? The answer is fact. It is absolutely true. Scientists estimate that the number of possible ways a snowflake can form is bigger, way bigger, than the estimated number of atoms in the entire universe. So yeah, the chances of 2 being exactly the same are pretty much 0.
So the next time you're outside and it starts to snow, take a second. Look closely at your sleeve. You're not just looking at frozen water. You are witnessing a one-of-a-kind piece of art created by an incredible journey through our atmosphere. So the only question left is, what secrets will you see?